All right, ladies and gentlemen, it's time for another edition of Name That Command Pattern. I'm your host, Mr. Ogunlana. No, I'm just playing. So, what we have in front of us is a GitHub repository called command-handler or dash pattern. And before I jump into what all of this is, basically I just want to give a brief idea of what this project was created for and some of the goals that I have with this project with regards to software development, with regards to my approach to software development. And so basically, I am a software developer that has been developing various softwares on a variety of platforms and runtimes for the past 15 years. And I have through the past 15 years, I have had experience on teams with individuals who I believe has high skill when it comes to architecture, design, and development. And I've had some up close and personal training by these individuals over the years. And so based on a lot of my experience in software development, especially, or I should say, with special emphasis on web, mobile, and desktop development, I have run into a variety of what is commonly known as design patterns. And these design patterns essentially are supposed to make the job of the developers of these software packages, software applications, mobile apps, etc. easy. It's supposed to make things straightforward. And essentially a design pattern is to a programmer what the English language is to a person who speaks it. And so essentially it provides for the software development team a form of communication, a way to communicate with each other utilizing thinking of a non-technical way to describe what a design pattern is. It essentially gives software developers a way to communicate with each other the process in which the software will be developed. So essentially a design pattern is it represents the philosophy, the approach, and or strategy and process into which the idea of the software gets morphed from the idea to a website or to a mobile device or to a desktop. So design patterns give developers, software developers, a straightforward way to solve common problems in software. Now, a lot of this, what I'm saying is discussed on various websites, and I've read many different books on software development, specifically the Gang of Four. They're known as the Gang of Four in software development, and they wrote a book some time ago, almost 30 years ago, about software development patterns that can be used in order to solve problems. And so from the outset, from that book to date, this is 2018, there have been many people in the software development community that have borrowed from some of those ideas discussed by the individuals who wrote that book to create essentially templates in which software developers can use to solve common problems. Common problem could be a customer client has a e-commerce website, some sort of retailing inventory website that kind of describe or that basically gives their users the means and platform to be placing orders with that software provider, to be getting products on a particular schedule. One example of a website like this is Amazon.com, and others. And so basically, people or organizations like Amazon have a variety of software systems that essentially automate the problem solving process for them. The problem is I have products that exist in a warehouse. I need the ability to sell these products and to track each point in the sales process so that I can begin to analyze my system, and progressively make the system better, make the system more user friendly, make the system more scalable, easy to use, so on and so forth. So using that example of that e-commerce system, there are several design patterns, so to speak, or templates, or approaches, so to speak, that software developers have come up with over the years to solve the problem of e-commerce on the web. And so there's some of the patterns, some of the philosophies that a lot of people should be familiar with, especially software developers, especially Microsoft or .NET developers, those who develop using the language of C#. It should be at least conversant in the design pattern called the N-tier design pattern, where the N-tier design pattern essentially it breaks the software system down into tiers, where you have essentially the UI or the user interface tier, which is represented by, especially in .NET or Microsoft, it's represented by the ASP runtime, or originally it was represented by the ASP runtime, and eventually spanned off into a variety of different runtimes that's supported by web browsers, which essentially these design patterns, or the runtimes, I should say, evolved as the technologies of the web browser evolved. So originally it was ASP, and this is around the time where Internet Explorer was first coming out. At that time there was no Chrome, and I don't believe Firefox was out. I think Netscape was out during that time, but definitely Internet Explorer was out during that time. And essentially the web runtime, which is considered to be the ASP.NET runtime, and this is ASP.NET 1.1, leading into 2.0, which essentially provided a lot of features for the software developer on that runtime that essentially made their job easier as technology and hardware began to evolve. And this is early 2000s, a little bit before, right at the turn of the century, during that time. So moving right along, as the technology and hardware began to progress, so that the software, so ASP went into what was known as ASP.NET. So I may have said ASP.NET at first, but the original runtime was ASP, active server pages, and essentially the runtime. This is the original one, 1.1. 1.0 essentially ran similar to the way that PHP runs its current runtime, where you inject things directly into the HTML. The language itself had the feel of a script language, where the difference was that there was some functionality built into the language, and into the compiler that enabled it to contact the server and to be doing things like data processing, so on and so forth. As things moved along from ASP 1.0, then came ASP.NET. Once ASP.NET hit the scene, there were a lot of different design patterns that came with it, because of the hardware and the technology of the browser began to permit more complexities on the web runtime. One design pattern that was utilized alongside the interior architecture or interior design pattern was a design pattern known as MVP. And essentially MVP was a carryover from the desktop runtime, where the client essentially was a piece of software that was installed on the computer, that when the user clicked the icon on the desktop, the user interface appeared, which essentially was the runtime. There were a couple other things about MVP that I'll discuss quickly. MVP, model view presenter. The presenter essentially was represented by that UI. And so one of the main things that architecture or design pattern touted, a lot of people call the architecture MVP, and then later MVC, and then later MVVM, and others. They tend to be called architectural approaches, because essentially they don't necessarily represent a particular design pattern. They essentially represent an idea that several patterns may manifest. So the .NET version of MVP was represented by the decoupling of the client or the UI from the server, or the part of the system that accessed the database and other server-oriented tasks. Not to get too into details with that, but wanted to at least give an idea of what MVP was. That led into, and there were some software shops that I had worked with during that time that utilized that software design approach, and they created different design patterns that these various shops called MVP. They're essentially their flavor. So MVP will be considered a soda, whereas the design pattern itself will be considered a particular flavor. So whereas MVP being the soda, the particular flavor of MVP varied from shop to shop. So some shops use the Sprite version of the MVP soda. Some shops use the Fanta version of it. But regardless of what flavor that was used, it was still widely known that the soda or the MVP idea was essentially being used to help to formulate a strategy and to give the means of communicating the problem, utilizing the philosophy of MVP from one software developer to another in the shop. So it still kind of provided that means to communicate. There are other design patterns I had mentioned, MVVM, which is essentially model, view, model. That was and it's still actually in process and still being utilized in the software community. I've seen a lot of the MVVM software design patterns being utilized in mobile app development, and speaking specifically from the Microsoft side of the community, so to speak. We see MVVM being utilized in some of the legacy Silverlight apps. And Silverlight is a web runtime that's similar to the action scripting from the Adobe shop. or the Adobe organization action script essentially was the language, and these ActiveX, not ActiveX objects. I need to figure out what the actual name is for the those components, but they were similar to the Flash components. And I'll use a different analogy. They're similar to the Javalets in that the Java runtime uses, or the Java organization has created to be the runtime for their web software development. And essentially, it was this all-encompassing component that gets embedded into the page that understands how to illustrate what it was being programmed to be illustrated using ActionScript and among other things. But not to get too caught up with that, the Silverlight, that's kind of what that was, and so we saw a lot of that fluid motion and some of the games and some of the mobile streaming types of software online using Silverlight. Also the WPF apps, which is another runtime, another language, so to speak. That is, it is an actual language. It's not a sort to speak, but it is actually a language that Microsoft also was responsible for presenting to the community. And WPF is the carryover, or I think is the evolution of the Silverlight runtime into more of a robust mobile specific kind of runtime. MVVM also was featured in some web apps. I saw some web apps utilize that architecture, but for the main part, I saw that design pattern be utilized, that philosophy be utilized for like mobile apps and web. So there's some other ones that are not as discussed, such as there's a distant cousin, so to speak, of the MVC architecture, and I believe it's called PAC. Have to look up the definition of the PAC, but it's essentially the client, or I've utilized the PAC architecture in a JavaScript architecture that I had developed. That is essentially, and I'll probably come out with that framework later on in the future. But essentially, it gives more fluid, because we see in MVC that, I've seen in MVC, like its concept of what a model is and how a model essentially gets translated into a view model, which essentially is the same object, just minus some of the domain specific properties that are not relevant to the client. And so the PAC model gives a little bit more fluidity on the modeling, whereas the model is really based on the UI usage of the model, and that particular model gets translated into a domain object. And so there are some interesting things that can be discussed on that, but not to get too caught up with that. This is really just a survey of some of the design patterns. So basically, over the years, ultimately, is what I'm trying to get at. We've saw in the software community multiple design patterns, multiple approaches, as technology has permitted and as technology has evolved. So I said all that to say that this is kind of what I've been pulling all of my experience from, past experiences working with some very, very intelligent people, my own research, and also my own projects. And so what I've come up with is something that's actually similar to another design pattern that is, or approach, and that is the bus design, which is essentially with the advent of distributed computing, websites like Amazon, as we all know, does not run on one server alone. On the contrary, Amazon runs on well, I know tens, probably hundreds of different servers. I wouldn't be surprised if it's thousands at this point, all around the world. But they all are essentially connected and distributed the I should say the data, the processing of this one app, Amazon.com, is distributed to all of these servers. And the way that it's being distributed is through what's known as busing. And essentially busing, if you think about a traditional bus or bus in real life terms, what is a bus? A bus is a vehicle essentially that transports something from one destination to the next. And so that's essentially the idea behind the bus architecture, where you have the bus is essentially the network, and the destination is essentially the server, and the process of getting the data from the user interface to the server is essentially distributed and based on this bus. And so just like a bus, you have, if you think local transportation, there are multiple buses, but they all go to the same place. That's essentially the same concept with the bus architecture. You have multiple buses, so to speak, that essentially all go to the same place, i.e. a data storage or something of that nature. And the bus understands vis-a-vis the bus driver how to get there. So the message on the bus carries the identification of where the data should go. Typically and I've seen some implementations of the busing architecture that you have essentially server A through C that exists, where you have server or the user that essentially exists outside of the server farm that is interfacing with the servers through the interface. And through that interface, let's just say it's a registration form. They hit the registration form to sign up. The information goes to essentially this port where the buses meet, and that port essentially kind of has an idea based on how many registrations have occurred at once, based on the load, which is the number of registrations at once, and other things of that nature. That essentially gives the bus driver, or the port gives the bus driver the map, so to speak, on which server to go to, and the bus driver gets that information and takes the package essentially to the particular port or the particular destination based on the directions. So that's a really, really, really long and probably very complicated definition for something that I saw in the bus architectures in various like enterprise level IT shops. And so what I want to say about that is the bus architecture is cool. I've seen a lot of different implementations of it, and I think what I've come up with is something that is a little bit more straightforward. I guess the target audience at this point of this, well, I guess at the point of this architecture is, I don't know. Well, let me say it this way. I don't want to box this in, but what I will say is that this software isn't based on, does not have any means to distribute the computing of the processing at this time, because I guess the scope of this design pattern is such that I guess right now, this is like the first time I've had to explain this out loud about this particular architecture per se. And so what I will say for about this one right now, the scope of this project is small to medium-sized organizations that have essentially a website, or essentially some web API or some sort of service that provides access to their database. And, essentially I'm just trying to, I guess what I'm trying to illustrate is that this version of the software that we see in front of us is really meant to be used on small to medium-sized corporations, small to medium-sized projects that do not have distributed computing as a part of the requirements. So essentially, if we think about how the market is segmented in terms of websites and software, there are wide, possibly million. Let me not say millions. Let's just Google it really fast. Well, instead of Googling right now, I'll just try to continue and not digress as much. But there are many corporations in the world that this software design would suit. I would say out of all of the projects that I've done in the last 15 years, this software design would probably be well suited for possibly 75% of them. While a lot of corporations tout being large, multi-million dollar corporations, tens, possibly hundreds of millions of dollars, their IT infrastructure essentially is still, I would consider, medium scale. What I would consider large scale software project is a website like Amazon, where it has literally millions of people coming from hundreds of countries online, purchasing possibly millions of products a day, where the problem is obvious that they need to distribute its computing. So all that being said, this I think is well suited for 75 to 80% of the projects, or 85% possibly of the small to medium-sized businesses, and then possibly even some of the larger businesses, depending on its infrastructure. And again, this is the first of possibly many videos that describe what this architecture. Simply because I wanted to, and I created this again to make the lives of software developers easy, especially the software developers that will be working with me on projects, because I utilize this architecture because, again, I think it's pretty straightforward. So with that being said, let's jump right into the command handler pattern. I probably will give it some cool name in the future. But for now, it's the command handler pattern. It can be accessed publicly at this GitHub URL. And so as we see here, we have a few projects here in this repository. We have the API Business Console Core and Entity project, which is common in projects that I create. One thing to note about this video, as well as one of my goals, is for the developers that will be helping me. I am creating this video to give them a means to essentially train them on how to use this command handler pattern, because it is essentially the design pattern that I use to develop server-side programming. So it will, all developers who will be helping me on various projects, they will be well suited if they go through this training, they go through this process to understand this. Now, the work, the actual documentation that will follow, should essentially and will be essentially a training document, and it will be meant to be straightforward. I know I've jumped around a lot in the video, but the video will be the document that will follow will essentially be a companion to this video that will essentially that will cut to the chase of the matter on what this is and why I created it, to essentially be to aid in training and onboarding new developers for server-side programming. So all of that being said, now let's kind of get into what I'm going to attempt to describe. As we see here, here's the project on GitHub. I also have it here in Visual Studio. Let me close all of these windows just so that we can get an idea of the project structure once again. As we see here, I have this project called an API. It is let's go to the project. It is a or ASP.NET MVC project that utilizes Microsoft's Web API technology. And so the Web API technology can be found in this project in the user controller. Now, I'm going to be jumping around sort of in this description because I'm still kind of gathering some of the thoughts, but I wanted to record a video on what some of this is, and just so that the documentation can begin to form. So this video is I'm going to make a couple of assumptions in this video, in the document that will be following the companion, that will be following, will make a couple of assumptions. The first assumption is that the person reading the companion, the person watching the video, has C# experience. At least C# experience, at least 3 to 5 years of C# experience, specifically utilizing the technologies of Web API 2. There's some other assumptions here. There are a few different technologies that I'm utilizing in order to make this whole project work. These technologies are not a requirement, but they are a nice to have for any developer to research, at least go through some of the documentation of some of these components, so that they can be up to speed on some of the ways that I'm pulling together this command handler pattern. One technology is AutoFact. AutoFact is a IOC container. So another assumption rather is in conjunction with, with 3 to 5 years of C# experience, that the developer also has and understands what an IOC container is and have experience using various IOC containers. There are many different IOC containers in the community of software development, especially in C#. Another example of an IOC container is the software called Ninject. I chose not to use Ninject because AutoFact has a easy to use fluent API, or at least easy for me to use and implement. The whole implementation was pretty straightforward. Another assumption here is that the developer also has ORM, object relational mapper experience. There are tons of different ORMs out in the software development community, in C# community. One is in Hibernate. Another one is the Entity Framework by Microsoft, and another one is Dapper. Dapper was created by an individual, I think Saffron from Stack Overflow had developed Dapper, and it is a very easy, straightforward to use ORM. I'm using their extension library for some other things. That's a nice to have to understand some of the extensions of Dapper, but again, the Dapper technology itself isn't a requirement. The requirement is, or the assumption is, that the developer has ORM experience. Looking through here to see if there's any other special libraries that developers also need to be familiar with. No, there. So there's we can, and so basically what I'd like and what will be in the actual training manual, so to speak, will be some instructions to create what's known as a command, or actually to create and I'm just going to go through what the goal of this will be for developers who successfully go through the training, which is to create a method within the user controller similar to the save method, utilizing the handler similar to how the command handler is being utilized here, to validate a new model similar to the user model that's being added or that's being referenced here, to create a new model, to actually, instead of creating a new model, because that's going to take a bunch of time and energy, I think instead of creating a new model, what will make the most sense is to essentially create another, or to do all of the development in the user controller, where the developer would essentially create a few different controller endpoints that utilize the user object. And so, as we see here, the handler, so to speak, and I am, again, one of the other assumptions here is there was another video that I did prior to this one that kind of had some information on what the handlers are, so to speak. And so some of that information should be included into the description of what the handler is. The project structure is essentially the same in the dev core as we see in the last video. Some of the same folders that kind of describe, that is essentially, similar to the folder structure of the last video. So instead of going into in-depth detail on what each thing is in here, I'm going to rely on that last video, and that last video should be relied on to pull some of the specifics on, or at least get an overview, so that as I kind of talk about some very specific things for this training manual that will be developed, the information from the prior video should also be utilized to describe some of the things that I do not go into detail here in this video on. So let's jump right in. So basically what I'd like is, and I'll do it here on the video just so that we see how it works. Basically what I want to do is I want to create a new method called update, and we're going to pass the user information in from the body of the post request. We're just going to take these attributes here. Another assumption is that and I think I've already said this, but I just want to say it just for my mind, as we can see, that we're using Web API, so that's just another requirement that Web API 2, the developer at least has experience in Web API 2, so that as I kind of go through this example, it makes sense to them. So basically, we're going to go ahead and update the route to user update. And essentially what I do, because this can be reused, is I just kind of copy and paste the handler information. There are some things that I'm going to talk about briefly. I'm not going to go into too much detail, but with how it works under the covers. What we will go into detail is some of these features here. So basically, we see this on a handler. We see this add, and what add does is adds model data, and model data is essentially any object that inherits from iModel. And so let's talk about that briefly. All entities in the software system that will be created using this command handler pattern will have a entity project, and within that entity project there will be a folder called models. And as we see here, if we just double click models, we see that it's essentially a class that inherits from this iModel interface. iModel interface is essentially a interface that has this one property, this underscore ID. All database tables will have, if it's represented by an entity in the models project, should have an underscore ID for the identity column, and that's what this is represented by. And so as we can see, it's just the user object just inherits that one column and then expounds a little bit more, as we can see, for that with user relevant information. So this add basically adds all models to the command, to this handler, I should say. And so going down here, we can see it has this whole concept of validators. Now, this whole concept of validators is key here because, and this is, I'm just pulling from my experience, and this is, as we can see, the way that this is designed is known as a Fluent API. Fluent API makes it easy to read, makes code easy to read. So at a glance here, we know what this entire workflow does. This entire workflow validates essentially the first name, the email, the password, confirmation password, and the both confirm and password to make sure that they match and that the email doesn't exist. This is what the validators do. And then after the validators occur, the commands come into play, where there's the user ID that's generated, the password of the user is hashed or encrypted, and then the actual user is saved. Another thing that we want to take a look at here is that the validators always occur first before the commands. So you could actually move these these validates here, but as we can see and I'll just show the implementation code just for posterity. As we can see, the validate commands occur first, then the actual commands occur second. So we can see, just going in depth, all of the validators are looped and its validation is checked, and if it's successful, it continues. So this is a very quick overview of what it is, simply because the idea of having this architecture is to essentially insulate the complexities of how validation occurs on the server from the developer. The main thing the developer needs to understand is how to create a validator. And a validator is essentially a class that inherits from this iValidation interface. This iValidation interface has is valid in a message. The message is essentially the string message that gets returned on if the validator is not valid. So As we can see, there's these validators. I've seen in my experience some very complicated validation libraries in the community. There are tons. Because I actually have a command handler design pattern, or this flavor of this command handler design pattern developed. I also included validators to it so that the data can, if it's validated on the client, the same validations can occur on the server, and the validation code can be insulated from the actual workflow development code so that each could be tested independently of each other, and an interface to describe what is validated is a little bit clearer instead of the validation code being nested within these commands here. So this was the whole idea of creating the validators. Just putting it back there just because I like to have my validators. I like to read it from top down, even though it does occur that way, but you can have the validator syntax anywhere on the handler, and the handler understands how to process the validators first before it processes the command. So we don't actually have to create, I don't have to create any new validators. Just for screenshotting and just so that we understand what each one does. We'll just kind of go through and click through and each one. As we can see, there's actually this one it loops through. The validators were developed with the concept of listing, or the validation occurring on a list of objects. This way, for single objects, the validation can occur, and then it also handles the list. So it takes, for example, this first name is not null or empty. It takes all the users off of the models by doing this data get. Data get is an extension off of the list iModel object. And so based off that list, you get for free a .get where you can pass it a type and it'll return you a list of all of the objects of that type. This is kind of one of the reasons why every object inherits from the iModel interface, which gives us the ability to do this. So I can say, give me all of my users off of the data, give me all of the users off of my data payload, and then iterate each user and make sure that if the username is null or empty, you're going to return a false, because the rule says the first name cannot be or is not null or empty. So that's what that does. The email not null or empty is similar. Basically, it takes the user off the data payload, iterates the list, and then checks the email. And if it is null or empty, it fails validation. And the message is email is required. The password not null or empty is essentially the same thing. The user list is retrieved from the payload, and the password is checked here to determine whether or not it's null or empty. And if it is, it fails validation and it passes a message, password is required. Confirm password not null or empty, again, the same thing. Iterates the list, or takes the user, iterates the list, and if the confirm password is null or empty, it returns a message, confirm password is required. Password and confirm password must match, similar thing. Basically, I take the user, get the list of users, and then I do a comparison on the password and confirm password. Basically, if the password is not equal to the confirmed password, validation fails with the message, password and confirmed password must match. Email not exist. Now this one has some goodies in it. As we see here, we got this iQuery object that is referencing, and it's being passed to the object constructor. Okay. And so it's being set. And so what this query object does, we'll go to the interface, is it gives us an interface to the database. We can do gets, insert, we can do all the CRUD updates, or excuse me, the CRUD operations on the database using this iQuery interface. The software knows how to instantiate this iQuery interface utilizing AutoFact. And so we're going to check out, let's just kind of go to AutoFact really, well, instead of me jumping, I'll complete my thought and then we'll go to the next point. And so the as we see, we get the query object, so we get database access. And so again, we pull the users off of the data payload, and then we iterate them and then we say we check the database on each user. Utilizing this exists, hanging off of this iQuery interface, and we pass it this statement, select user, from this email, from the user email, and then the exist returns a Boolean or a true false. Now, if the user exists by this email, it's going to return a false. If it does not exist, it's going to return true. If it does exist, we get the message email taken. Okay. Now, before we go on to the commands, I want to go to the implementation of AutoFact, and so just so that we'll understand what it is, or how the software, how the IOC container is set up. As we can see, there's a handler that is the default handler for the system that essentially invokes the commands based on a data payload. We also have this SQL query, which is essentially the instantiated or the concrete implementation of this iQuery interface. The SQL query is essentially the SQL Server query object, and it interfaces directly with SQL Server. We have some basic encryption encryptors, AES Base64 encryptor, and this is for hashing the password. We'll get to that in a moment. All of the encryptors are found based and is scanned when the application is loaded, based off of this iString encryptor interface. For all intents and purposes of this video and for the subsequent training document to onboard new developers, this can be ignored for now. Because if there's any other string or encryptors that need to be made, further documentation in other videos will be made to kind of describe that, but for now we can skip it because the ones that we need have already been developed. The validators, though, iValidation, so one of the things that I will need for the developer to do as they go through this training is to create a validator, and I'll kind of give some instruction on that here in a second once we get back to the controller, but I at least wanted to show that all validators, as long as they inherit this iValidation interface, will be scanned and will be added to the IOC container as well as the commands. As we can see, as long as it inherits from this iCommand interface, it will be found and it will be added. So no additional thing needs to be done, just the object, and the object inheriting from this interface is enough for it to be included in the project. And that's it for the IOC container. Now, getting back into this handler, as we see, the add adds the user, the validate validates the email, password, confirmation password, and then now we get to the commands. Now the commands execute based on the sequence of based on their sequence. So the commands, the group of commands can exist anywhere I guess vertically here in the Fluent API of this handler, but in the group of commands, the execution for the commands occurs sequentially. So, for example, as we see here, the generate user ID comes before hash user password, which comes before save user, right? So this is the first one that occurs. This is the second one that occurs. This is the third. This is the third command that executes. Now if I move the commands here, the same thing applies. The first one occurs is to generate user ID, so on and so forth. If I move them here, the first one that occurs is to generate, the next one is the hash, the next one is the save. The same thing goes for the validate. It's based on the group itself, and so if I have something like this validator would execute first still, this one second, third, fourth, fifth, so on. Just wanted to show that just so that I know that this, since it's using a Fluent API, it can be confusing on where and how things should flow. I guess the general idea is based on the group. So if you're creating a validator, if you have validators that occur, all validators occur first, and within the group of validators, it flows sequentially from top to bottom based on how if we see it here vertically. So if we maintain that, we can understand the execution flow. So now for a command, we have this generate user ID. Generate user ID, we're gonna go quickly to that command. As we see, it's not much in here. And that's the point. The point for each command is the goal, I should say, excuse me, tongue twister, should say, is that each command should have only the code that's necessary to execute one atomic task at a time. This is what a command is. A command, so basically, what I want to see in developers in creating commands is very small, very lightweight commands. To create very small, lightweight commands that only do one thing. And I would rather there be hundreds of commands in the system that they all do one thing than to have 10 that do 100 things within them. So that hopefully makes sense, or hopefully it can be illustrated in a way that it makes sense in the documentation, I should say. But basically, we see here that the only thing that this generate user ID does is it gets the users off the stack using this data get. I'm going to do something here. Using this data get, and from this data get, we see that we get the collection of users, and all of this command does is it iterates the users, because again, the whole idea is that work will be done on a list of objects. And so basically I take each user and iterate them and set their ID to what's called a new unique identifier. So that's essentially all this command does. This does that because in our database, the ID is a unique identifier, which isn't generated. We have the code, which is what identifies or produces that identifier. Whereas this underscore ID is just the count, which will differ from production to develop to stage environments. But the one thing that may remain the same and that typically will remain the same is the ID. As we can see, a lot of tables, or the tables that exist, as I was saying earlier, it has the underscore ID and it has this ID. There's some other conventions that hopefully will be coming out as I continue to describe this. But that's essentially what this one command does. The next command, it hashes the password. And as you guessed it, we take this encryptor and we instantiate it. And based on the instantiation, we take the list of users off of the payload, we iterate the users, and we essentially encrypt the password based on the kind of encryptor that we want to pass. Okay, so that's just so that we understand what's happening here. Again, we have one command called hash password, and as we see, it only hashes the password. It does nothing else. That's essentially what I would consider a valid command. If a command does many different tasks, then what I would say is that the command needs to be abstracted, or the tasks themselves need to be abstracted into several different commands, so that way we maintain the simplicity in the code, the readability of the code, and the reusability of the code. And save user, as you guessed it, saves the user. Again, it takes this, it gets this iQuery object using the IOC container. And again, this is all this object does, is it saves users. Now, as we can see, this is now for developers that will be helping with projects in the future. Essentially, this is the main thing that you would need to do. You could essentially copy a handler that already has a chain. You can begin to code into that handler. You can begin to code into that handler validators, and then also be adding commands, and that's essentially it. Now, what I just did was copy this. Now, one thing that we will do right now, I'm in the controller. I'll go ahead and save this. Right now, I'm in the controller, but what I'd actually like is, at least for the test or the training purpose, I should say, is for the console project to be used. And this is just a project that has been set up, everything that has been set up with the IOC container. As we can see here, all of the IOC container configurations have already been added to it. And essentially, we see this handler being resolved in essentially the same stack of validators and commands. This project can be utilized to test the command that's created and the validator that's created first. So I'm just going to run this to show the results of this chain, which is essentially should be a new user. So we'll say first on test, we'll change some things around, test, and then we're just going to give this a go. We're going to start it up. We're going to step right through that. The IOC container was registered, and we're just going to let this go. Right? The results, as we can see, if there's an issue with something going on the object, we'll see the message here. But as we see, the object has been created, password has been hashed, and we're going to verify that in the database. Go ahead and verify that in the database. As we can see, here's the user we just created. Now, one thing about this database, as we can see, it's just 3 tables. There's actually a script. See if I can get to that script really fast. Projects. Command. Okay. There's a folder called command, there's a folder in the project on the GitHub repository that will be added. It wasn't there when I just did it, but we'll go ahead and add it now, actually. Well, we'll do it here in a second. It'll be there by the time anyone checks the Git repository. But there's a folder with a create script that essentially has the create script for the 3 tables here. Go ahead and run that on your local SQL Server instance. Another requirement, for at least for the training purposes, is SQL Server 2008, 2004, 2014, or at least 2008. At least have a version of SQL Server 2008 installed, if not 2014. And this script can be run to go ahead and generate those tables for you. And then all you would need to do in the project itself is go to the dev.console project, into the app.config, and verify that the database that script for those 3 tables was run under is called command db, and it's on your local host. That's essentially the only thing that's necessary. So essentially this is, I guess, on the first thing, what I would require is for all new developers at least to find this. I'm gonna leave this inside of the console project just so that it can be reviewed. I at least just wanted to bring the attention to this just so that it can be tested. So the first thing I want to do, I'm just going to enumerate a couple things that I want developers to do in the training, is to create another validator here. That, go ahead and stop it. Let's look at this user object here. To create another field on the user object. I'm thinking about this now. Actually, instead of creating another field on the user object, what we'll do is I want another. So the first thing that I'd like is for the developer to create another validator that verifies the username. And when the validator is created, I'll just go through it really quickly here, just for example's sakes. So we'll go to where the validator should be placed, which is in the business project. There's a folder called validators that already has a folder called users. What I'm going to go ahead and do is copy this password not empty, and we'll just say, instead of password, we're going to call it username not empty. And essentially what it's going to do is, did I already create something there? Let's go ahead and delete that. So basically what we're going to do is get Visual Studio to work. 1 second. Let's go ahead and get rid of this. And then let's go ahead and create this validator called username not null or empty. We'll go ahead and open it up. Update the object name. Essentially, the only things that need to be done here is to update the message to say username is required, and then here where we say password is null or not empty, the only thing that we have to do is go to username not empty, right? And then that's it. It already inherits from the iValidation interface, so the IOC container will pick this up. Okay, so what we're going to do is we're going to go ahead and run this without adding the username, and we're going to go ahead and add the validator, but I'm not going to add the username to the object just so that we can see the message. So we add the validator like that to this command chain. So now what's going to happen on this user object, it's going to try to, this command chain, before it executes the commands, it's going to run these validators. And when it gets to this username not null or empty, it should find that the username hasn't been set here. We've only set the first, last, email, password, or confirm password, but we did not set the username, so it should error out. So let's go ahead and run this. And we're going to look at the result. And as we see, it says username is required. So what we want to do is, in the result, you can see the success is false. And the message, the username is required. So it did not save the user. And the reason why is because the username is required. So we're going to go ahead and add the username. And we're going to call this Mr. Ogunlana. Now that we've added the username, the validator, username not null or empty, should pass, and the user should actually get created. So we're going to call this user with pass. Okay, I'm going to go ahead and run this. I'm going to check the result. As we can see, it was successful, and it appears, at least in the code, that the object got created. We can go ahead and verify this. And as we can see, the user with the password, Mr. Ogunlana, was created. So essentially, that's what I want for the first step of the training in terms of creating a validator. I'm going to go ahead and delete that validator for now. The second thing is for the command. What I like is thinking of a command that can be done on the user object. Give me 1 second. This is what we'll do. I'll go ahead and generate a role ID. So we're going to create that as a command. So if we go back to the dev business and we go to the commands, this is where the commands should be created. So what we're gonna do, since we already have a command that's similar to that, so we'll go ahead and copy that. And we're gonna say generate role ID. I'm gonna go to this command, update the class name. And essentially, the main thing that we need to do here is change this from ID to role ID. Role ID, this wouldn't typically be set like this, but for all intents and purposes, this at least gives the practice of creating a command and updating essentially the data set based off of some business process. So what we're going to do is we're going to add generate role ID to the command chain. Again, the IOC container picks up all commands as well as validators as long as it inherits from this iCommand interface. That's essentially the only thing that you have to worry about with the system, helping the system to understand that you created the command and then you just reference your command using this syntax from the handler. So now I'm going to say user with role ID. So now a new user should be created with a role ID now because of this command. So now we're going to go ahead and save that. We're going to go ahead and run it. We're going to check it out. says it was successful. As we see, the role ID is set. I'm going to verify this in the database. As we see, the fourth user created with the role ID as we desired. I'm going to go ahead and delete this command because I want developers to create one. Now, so that's essentially the main two things that I want. One other thing that I want to emphasize is and stress essentially in terms of some things to familiarize yourself with, along with creating validators and commands, is to spend some time understanding and playing with essentially this iQuery object. So what I would do is create another entity in the database, possibly maybe an address table, then creating an entity called address that will essentially be a copy of the user class with just address information in it, and it should inherit from the iModel interface. Also, to create a map, which will for that entity, which essentially be a copy of this user interface. One thing that I will mention for the maps, this is using that Dapper extensions library, and it essentially you specify, and if you use this as an example, you'll have this for free, and it shouldn't take you a lot of time or a developer a lot of time to kind of get the grips or the gist of how this design pattern, this architecture is utilizing these extensions. But essentially the table name goes first. So the address would go here. This will remain the same because again, the underscore ID should exist on that table. The table should also have, the address table should have the underscore ID, which is the primary key, and an identity column. And the ID should be a unique identifier. If you look at the design of the user table, you should be able to get the gist, or the developer should be able to get the gist of how to set it up. The ID, the underscore ID should be the design or the identity column, and the primary key field, as we see here. It is the primary key. And then you'll have some address fields here. As typically what I do standard on tables that I create is I put on the table created and modified. And so 4 columns should be in the address column or in the address table. Underscore ID, ID, created, modified. And then there should be some subsequent columns. The address line 1, address line 2, city, state, zip, all of those can be varchar fields. Just for example's sakes, no need to get into trying to create a state table and pass IDs or anything. The main thing to note is that the address map would have a class mapper, would inherit from that class mapper. The address map would inherit from the class mapper, which will essentially be utilizing the address object here instead of the user one. The table should be address, this should be copied, and this should be copied. The address map wouldn't need these two fields, or it wouldn't need this field. It would need this syntax because the created is read only. Another thing that I did on the user table or model that should be copied is setting the modified date. So once the model and its map, as well as the table is created, what I would do is create a sequence of validators to validate the address, city, state, zip, as well as to generate the address ID and to actually save the address on the table utilizing the query object in a similar fashion that the query object is saved here. Now, what I would say just by way of organizing, the validators for the address should exist in the address folder. The commands would exist here, and they can be separated by folders. So that's that. This is complete. That part of the training is also it's optional, but I believe will give a solid understanding of how to essentially create entities, or essentially create data tables using some of the base template ID _ID created modified as the template, and then adding the subsequent columns to create a model that represents that table, to create a map that helps Dapper to understand how to run CRUD operations on that table, and then to implement a command or series of commands that act on it, as well as validators, just to confirm that at least going through that process will at least help and confirm that, or at least will confirm for me that the developer at least has is at least conversant and familiar enough with the command architecture that or at least how it's illustrated here, so that they can begin helping with server development. Just thinking if there's anything else that I want to go over. No, I think that's it. So again, this is the command handler. I am your host, Diran Ogunlana. I did once again develop this to try to make it easy to use for developers, especially web APIs, server-side programming. It is Bus inspired, and hopefully my description wasn't too confusing. And stay tuned for future videos on the command handler. Thanks for your time.